Hello everyone, welcome to the fourth and the last project of Ionots IoT course. In the previous projects, we have already designed different projects for controlling LED and used PIR sensor for theft prevention. In this project, we will build a fire detection system to detect fire and prevent accidents that are caused by fire. This project comprises of smoke and temperature sensor that are calibrated to detect temperature and smoke at certain level. These sensors will detect any fire whenever temperature or smoke value rises above the threshold level, and then the result will be passed on to the Blink platform, thus notifying the mobile device of the owner. Now, moving on to the project. Hardware requirements for this project are Node MCU, gas sensor, BMP280 sensor, breadboard, micro USB cable, jumper wires. Gas sensors and BMP280 sensors are already covered in the theory part. Now, for the software requirement, there are Arduino IDE and Blink application. We have used both the software in the previous projects. Coming to the procedure, step 1. Open Arduino IDE, install Adafruit BMP280 and Blink libraries from Manage Library. Now we'll go to the Arduino IDE, go to the sketch, in include library, go to Manage Libraries. In Library Manager, you can install any library for IoT projects or embedded system project. In the search bar, enter Adafruit BMP and then hit enter. Here there are a lot of BMP libraries. Let's be specific, enter BMP280. Here it is, Adafruit BMP280 libraries. As you can see, I have already installed it on my machine. Now we will go for Blink library. This might be a little slow because of your machine or network connection. Now you can see I have already installed Blink library here. Now we'll close the library manager. We'll go to the step 2, copy and paste the source code in the Arduino IDE. As you already know, source code is present at the end of procedure. We'll go to the source code, select the source code, just hold on a minute. Just hold shift and press down arrow so you can select the source code. Now copy it and paste it in the Arduino IDE. Now hit Ctrl A on your keyboard, right click on the Arduino IDE and here click auto format. This will format your code and make it look better. Now we'll move on to the next step. Step number 3 says create a project in Blink application and configure the project for notification. Now before moving to the Blink application, we will save our Arduino IDE code. Here, press Ctrl S. I'll save it on my desktop with the name project_4 and then press save. After saving the code in Arduino IDE, we will create a Blink project. For that, go to your Blink application. In the Blink application, select New Project. Here, give it a name. I'll name it project_4. Then select your device. Here we will select Node MCU. Then select connection type, that is Wi-Fi, and then create. As you can see, an authorization token was sent to the respective email has been shown here. Press OK. Now on the project for GUI, click plus on the top right of the screen. Here scroll down a little and in the notifications you will see notification. Import this in your GUI just by tapping on it, and here you can see the notification is here. I'll bring it in the middle of the screen, and that's it. Now we will copy the authorization token of the project and paste it in the Arduino IDE. After we have successfully created a project in Blink application, we will move on to the next step. Step number 4 says enter the authorization token, network ID, password at the required places in the code. First of all, we'll look for the authorization token in our mail. We'll go to the mail and here look for the email from the Blink. Here you can see that's the top one, and check for authorization token. We'll select the authorization token and copy it. Now we'll go to the Arduino IDE. In the line number 9, you can see hash symbol. We'll replace hash symbol with the authorization token. In line number 10, you can see SSID. Here we'll enter our Wi-Fi name. In line number 11, for the pass, we'll enter the Wi-Fi password. Now we are done entering the credential in the project. Now this code has been written for the industrial purpose that we actually utilize in our industry. Here the threshold values are set as per the real temperature and real smoke values. We will change that as we are using in our home. So for the smoke threshold value, we'll enter 0, so it will detect any change in the smoke. And for temperature, I'll enter the room temperature, that is 25 degrees Celsius. Now our code is ready. Now we'll move on to the next step. Step number 5 says check once whether you have selected the right board and the COM port before uploading the code, then upload the code. Now I'll go back to the Arduino IDE. Here I'll plug in my Node MCU in my system. Now I'll look in the tools. In the tools, you can see I've selected the right board, that is Node MCU 1.0, and I'll check for the port COM4. This confirms that my Node MCU is connected to the system. Now I'll upload the code in the Node MCU. Successfully uploaded the code in our Node MCU. Now we can move forward with the hardware assembly. So first of all, remove the micro USB cable from Node MCU to ensure the safety of your hardware. I have already placed the sensor on the breadboard. While placing the sensor on the breadboard, just be gentle, don't apply too much pressure, else you might break the sensor as these pins are very sensitive. Now gas sensor comprises of 4 pins. One is for analog input, second is for digital input, third is for ground, and fourth one is for VCC. We will be using analog input in our project, so we will not connect digital input to any pin. Now first pin is analog input. We'll connect analog input to the analog 0 of the node MCU. Second pin is digital input. We will leave it. Third pin is ground. We'll connect ground to the ground of node MCU. Fourth pin is VCC. We'll connect VCC of sensor to the 3.3 volt of node MCU. Now moving on to the temperature sensor. Temperature sensor has 6 pins, but we are using I2C protocol, so we'll be utilizing only 4 pins that are VCC, ground, SCL and SDA. The first pin here is VCC. We'll connect VCC to the other 3.3 volt of node MCU. Second pin is ground. We'll connect ground of the temperature sensor to the 3.3 volt of node MCU. Third pin is SCL. We'll connect SCL to the D1 of node MCU. Fourth pin is SDA. We'll connect SDA to the D2 of node MCU. Now while connecting the pins, just remember the name of the pin that are written on the sensor and connect to the node MCU that are written on the node MCU itself. We have successfully completed our connections. Now we can go on with the demonstration of the project. We have finished the hardware assembly. Now we'll plug in our node MCU to the system. As we have already uploaded the code in the node MCU in previous steps, we can move forward with the results. We'll go to the Blink application. In the Blink application, on the top right of the screen, you can see a play button. We'll tap on it, and as you can see on the screen, it says alert, fire in the premises. This was the message that was entered in the Arduino ID in case of fire. As our temperature is set to the room temperature, that is 25 degrees Celsius, it will keep on printing it. Now I'll go back. And you can see in the notification, it says alert, fire in the premises. Now when you deploy this application, it will notify you whenever there is a fire, although you need to set the temperature back to 300 degrees Celsius. Thus, we have concluded our project. You can deploy this project in your house or workspace. You might have noticed such systems are present in most of the buildings and they have water sprinklers attached with them. You can also do the same by integrating a small pump motor in the circuit and modifying the source code in the loop. Now, you have finished 4 different projects. You can mix the input and output of these projects and make a new project out of it. All you need is your creativity. The project that we have built here so far are the systems that are being deployed in real life. For example, you might have noticed a smart light or appliances that can be controlled using your mobile phone, or anti-theft detection system that is present in most of the banks and museums today, or fire prevention system that is present in most of the buildings and hotels. You may also deploy such system in your premises and make your own smart house. I hope you learned some new stuff in this course, and if you have any doubts regarding the theory or projects, you are free to ask them in the forums.